Hello, I am K.S. Pujari, Professor in Mechanical Engineering Department at KLS VDIT here. Today I am continuing that module number 5, that is game theory. In previous class, you studied about principle of dominance and also solved some of the numericals on and implementation of the dominance rule. Further, after implementation of dominance rule, the reduced matrix is 2 by 2, and also you studied about that application of arithmetic mean. Okay, so in today's class you are studying that solution of 2 by m or n by 2 payoff matrix by graphical method and further implementation of arithmetic mean to 2 by 2 payoff matrix. So today's study is exhibiting the memory of previously learned material by recalling the facts, terms, basics and concepts. So it is mapping with Bloom taxonomy L1 and L2. Okay. Let us see that numerical on that 2 by m or n by 2 payoff matrix and solving it by graphical method. Okay. So this is a given payoff matrix. There are two players, player A and player B. Okay. So player A have 4 strategies, player B have 4 strategies, that is y1, y2, y3 and y4. Similarly for player A, x1, x2, x3 and x4. So positive value in this matrix indicates that is gain to player A, similarly that is loss to player B, and negative value in this matrix indicates that is loss to player A and gain to player B. So whenever you are solving any payoff matrix, first you have to check for the existence of saddle point. For that one you have to determine minimum in each row. So first row minimum value is 5, second row minimum value is 3, third row minimum value is 4, fourth row minimum value is -1. Among this minimum value, maximum value is that is 5. Okay, find maximum in each column. So maximum in first column is 19, maximum in second column is 8, maximum in third column is 18, maximum in fourth column is 6. So minimum of these maximum values, that is 6. So minimum of maximum and maximum of minimum not equal to each other. So there no existence of saddle point. So further you have to apply dominance rule for reducing the order of matrix. Here order of matrix is 4 by 4. So you are applying dominance rule. So reduce this 4 by 4 to other or lower order matrix. Okay. So there are 4 types of dominance rule: row dominance rule, column dominance rule, average row dominance rule, average column dominance. Apply one by one starting from row dominance rule. Row dominance rule, it states that select any one of the row. There are 4 rows here, x1, x2, x3 and x4. Select any one of the row and comparing with any one of the remaining row. Okay, if selected row values are less than or equal to any one of the remaining row, then delete the selected row. For example, if you selected x2, comparing with any one of the remaining row, suppose x2 you are comparing with x1, 7 less than 19, 3 less than 6, but 14 is not less than 7. So it is not accepted. It means row dominance rule not fit between 7 and 14. Okay, selected row is x2 comparing with x1. Okay, if selected row values, these row values are less than or equal to this x1 row, then delete x2 or compare this x2 row with x3. Okay, 7 less than 12 accepted, 3 less than 8, but 14 is less than 18 accepted, but 6 is not less than 4, it is not accepted. It means row dominance rule not fit. Okay, like this, when you go on comparing each row with any one of the remaining row, by all combinations, that row dominance rule is not fit. Okay, then you have to go for next dominance rule, that is column dominance rule. It states that select any one of the column, okay, either y1, y2, y3 or y4, any one of the column. Compare with any one of the remaining column. Okay, if selected column values are greater than or equal to any one of the remaining column, then delete the selected column. For example, select this y1 column. Okay, compare with y2. This 19 is greater than 6, accepted. 7 is greater than 3, accepted. 12 greater than 8, accepted. 8 greater than 7, accepted. So, between y1 and y2, column dominance rule is fit. So, delete y1. Okay. Similarly, comparing y3 column values with y4. 7 greater than 5, accepted. Okay. 14 greater than 6, accepted. 18 greater than 4, accepted. 13 greater than -1, accepted. So delete column y3. But y2, when you compare with y4, 6 greater than 5, accepted. 3 not greater than this 6. So column dominance rule not fit between y2 and y4 or y4 and y2. Okay, here it not fits between y2 and y4, even between y2 and y3 it not fit. So deleted columns are y1 and y3. So reduced matrix is that that 4 by 2. Initially order of matrix is 4 by 4. Now order of matrix is 4 by 2. See here, in a dominance rule, order of the matrix is reducing. Okay. Once again check, is there any remaining dominance rule fit to this reduced matrix? Okay, that is applying row dominance rule. Okay, row dominance rule between x3 and x4. Okay, x3 and x4. Okay, or x4 and x3. 7 is less than 8, accepted. -1 less than 4, accepted. Selected row is x4 and comparing with x3. Okay, 7 less than 8, accepted. Okay, -1 less than 4, accepted. Okay, so deleting x4 row. Now reduced matrix is like this. Now the order of matrix is 3 by 2. See here, earlier order of matrix is 4 by 2. Now it is reduced to 3 by 2. Further, check, can we apply any dominance rule? For example, starting from row dominance. x2, 3 comparing with x1. 3 less than 6, accepted. But 6 is not less than 5, it is not accepted. So between x2 and x1, it not fit. Okay. Similarly, between x2 and x3, it not fit. Similarly, between x1 and x2, it not fit. Even column wise also, 6 greater than 5, accepted. But 3 is not greater than 6, it not accepted. So row and column dominance rule not fit here. You want check for the average row dominance. Average row dominance means select any two rows, find its average. For example, if you take average of x1 and x2, x1 and x2 average is 6 plus 3, that is 9, 4.5, and 5 plus 6, that 5.5. So new values are 4.5 and other one is 5.5. Okay. Compare with the remaining row. Remaining row is this one. If we are comparing with that remaining row, selected row, okay, new values are, that is 4.5, 5.5. These are the new values. Select remaining row. Remaining row only one, selected one is. If selected row value is less than that new value, new values are 4.5, but here it is 8, it not accepted. And here 4, that is that less than 5.5, it is accepted, but here it is greater. So average row dominance rule also not fit. Column average column dominance rule you cannot apply, because average column dominance rule you can apply if only that the number of columns are more than 2, but here it is only 2. So finally reduced matrix after applying dominance rule is, that is n by 2. Okay, graphical solution, graphical method can be applied if matrix is n by 2. It means any number of rows and 2 columns, or 2 rows any number of columns. Okay, graphical method can apply only if any number of rows, 2 columns, or 2 rows any number of columns. Presently that n rows and 2 columns. So graphical method can apply. So further graphical method objective is to reduce the matrix. Here order of the matrix is 3 by 2. Further you are applying graphical method so that matrix reduce to lower order. For that one, here y4, no, here first column is y2 here. Okay, first column is y2, so you have to determine expected payoff from that player B. Okay, assume this y4 equal to 1 minus y2, 1 minus y2, y4 equal to 1 minus y2. Okay, here you make 2 column, A pure strategies, that is x1, x2 and x3, and B is expected payoff. Okay, so here how to write these equations? Okay, 6 into y2 plus here y4 you are substituting as 1 minus y2, 5 into y4, that is 5 into y1 minus y2. So when you solve it, that is becomes y2 plus y5. Similarly for x2, 3 into y2, okay, 3y2 plus 6 into 1 minus y2, it is minus 3y2 plus 6. Similarly 8 into y2, 8y2 plus 4 into 1 minus y2, 4y2 plus 4. Okay, so this is how to write this expected payoff, that linear equation. Now for each linear equation you are drawing one linear line. Okay, this graph. Okay, this graph you are drawing referring to this matrix. Okay, here y2 and y4. Okay, for each one you have to write one linear line, vertical linear line like this, here for y2 and this is for y4. Between these two you take convenient distance and divide into 4 parts. First part 0.25, second part 0.5, third point 0.75 and 4. Keep it in your mind, the distance between these two is as per your convenience. Okay, better take that 10 centimeter, even 8 centimeter also you can consider. Divide it into 4 parts like this, 0.25, 0.5, 0.75. And how much this vertical scale here on y2 line and y4. Okay, y2 here, in y2 maximum positive value is 8 and y4 maximum positive value is 6. So maximum of this y2 and y4 column is 8, positive 8. So take on positive side only, 8. Here 1 centimeter go to 1 unit. Okay, scale, that is 1 centimeter go to 1 unit to 8, and here also 0 to 8. Okay, so keep it in your mind, 2 columns, so 2 lines here, y2 and y4. Okay, distance between these two as per your convenience. For easy purpose 10 centimeter, even 8 centimeter. Okay, and this is scale, unit scale 1 centimeter go to 1 unit, or else 1 centimeter to 2 unit, as per your convenience. Okay, but scale must be same on both side. Okay, maximum values on this linear line, okay, depending upon this what column cell values. Okay, column cell maximum value here, maximum value in this matrix is, it is 8. So on both line you take 8. Okay, now go on drawing these lines referring to this matrix only. Okay, x1 line, y2 value is 6. Okay, so y2 column 6, here 6. Okay, mark this one as 6. And x1 y4 is 5. Okay, 6 and 5, 6 and 5. Join these two by a linear line. Okay, this is for strategy x1. Okay, strategy x1. Similarly for x2, y2 is 3, y4 is 6. Okay, 3 and 6. Join these two by linear line, that is x2. Similarly, third one, 8 and 4. Okay, 8 and 4. Okay, join these two by linear line. Okay, this is x3. Okay, this is x3. Okay, so this is how to construct linear line for each strategy in n by 2 matrix, n by 2 payoff matrix. Okay, whenever the matrix payoff matrix is n by 2, whenever payoff matrix is n by 2, then find the uppermost boundary. Okay, uppermost boundary like this. Okay, as I made now this region, hatching region, this is uppermost boundary. Okay, uppermost boundary. Okay, this one, okay, along this one, okay, along this one, above this one is the feasible region. Okay, this is upper boundary. In this upper boundary, find the intersection point. Intersection with this line is here, this is 1, second one is this one, and third one is this one, and fourth one is this one. Among these four, lowest one towards this one, toward this one is this one. Okay, this is minimum of maximum. Why it is called maximum? This is the maximum region. In this maximum region, you are determining minimum. Okay, minimum of maximum. This minimum of maximum is intersection of x1 and x2. Okay, this minimum of intersection point, minimum of maximum intersection point, it is an intersection of x1 and x2. So among the three strategies, remaining strategies are x1 and x2 only. Okay, here, see here, I deleted x3 row and remaining row is x1 and x2. See here, order of matrix is reduced. Earlier order of matrix is 3 by 2. Now it is reduced to 2 by 2. This is the objective of graphical method. Graphical method, any n by 2 order matrix, okay, n by 2, any number of rows, 2 columns, then you can reduce it to 2 by 2 like this. Okay, this is how to reduce the n by 2 matrix to 2 by 2 by graphical method. Okay, now matrix is reduced to 2 by 2. Further, you are solving it by arithmetic mean method as usual, as you did in previous class. Okay, determining row ornaments. Okay, that is different for x1 row, difference of adjacent row and its modulus. 3 minus x minus 3, its modulus is 3. For x2 row, 6 minus 5, 1 and its modulus is 1. So these are the row ornaments. Similarly for column ornaments, 5 and 6 difference is 1, 6 and 3 difference is 3. Okay, its modulus is 1, that is 1 and 3 for the column ornaments. Now these are the row ornaments and column ornaments. Okay, now you are determining game value. Okay, game value by using row ornaments or else column ornaments. If you are using row ornaments, okay, if you are using row ornaments, 3 into select any one of the column y2 or y4. If you selected y2 column, 3 into 6, okay, as written here, 3 and that's 6 into 3 and 3 into 1, okay, 3 into 1 divided by 3 plus 1, summation of 3 that ornaments, that game value is 21 by 4. If you selected y4, okay, 3 into 5, okay, 3 into 5 or 5 into 3 plus 6 into 1, that is 1 to 6, okay, divided by 3 plus 1, here also 21 by 4. Select any one, no need to calculate both, any one. This is just for the cross check. Okay, in examination you can do that cross check, or else you select one column for the row ornaments and one row for the column ornaments. Even by column ornaments also you will get same value. Okay, select any one row, 6 into 1, 6 plus 5 into 3, 15. 15 plus 6 is 21 divided by 4. Okay, here also divided by 4 using column ornaments. Even this row also, 3 into 1 plus 18. 18 plus 3 is 21 divided by 4. Okay, using column and ornaments also you are getting same game value. This is how to determine game value by using ornaments. Here the reduced matrix is 2 by 2. So it is an mixed strategy. Then what is the percentage of that each strategy? For x1, 3 divided by 3 plus 1, that is 3 by 4. x2, 1 divided by 3 plus 1, that is 1 by 4. Okay. Similarly for y2, 1 divided by 1 plus 3, that is 1 by 4. 3 divided by 1 plus 3, 3 by 4. Okay. For player 8, 4 strategies, x1, x2, x3 and x4. So optimal strategies are x1, 3 by 4 and x2, 1 by 4 and remaining strategies are 0, 0. Similarly player B, y1, y2, y3 and y4. y1 that 0, y2 is 1 by 4, y3 0, y4 is 3 by 4. Game value is 21 by 4. Okay, this is how to implement that graphical method for reducing the matrix and determining game value by arithmetic mean. So keep it in your mind, whenever that order of matrix is n by 2, any number of rows and 2 columns, you have to determine uppermost boundary and that minimum of maximum. Okay, let us go to other game. Okay, payoff matrix, and he asked to solve by graphical method. So clearly mentioned, apply graphical method. Okay. Now here given matrix, check for the saddle point, minimum in each row, that is minus 5, minus 5, maximum of minimum is that is minus 5, and maximum in each column, these are the maximum in each column, minimum of maximum 0, 0 and minus 5 not equal to each other, no existence of saddle point. But he clearly mentioned solve it by graphical method. It means you have to reduce the matrix by graphical method only, and you can apply graphical method because the order of matrix is 2 by m. For n by 2, 2 by m, you can apply graphical method, So directly you are applying graphical method without any dominance rule. Okay, no need to apply because clearly mentioned solve it by graphical method only. Okay, you can implement graphical method because order of matrix is 2 by m. Okay, so applying graphical method to reduce the order of matrix. Presently order of matrix is 2 by 5. Let us apply graphical method, okay, to reduce the matrix. Here x1 and x2. Let us assume x2 is equal to 1 minus x1. Okay, right? Payoff matrix. A is payoff matrix. Okay. B's payoff strategies are y1, y2, y3 and y4, y5. Expected payoff minus 5 into x1 plus 8 into 1 minus x1 and solve it, that is minus 13 x1 plus 8. Similarly for second one, 5 into x1 minus 4 into 1 minus x1, that 9 x1 minus 4. And similarly for y3, 0 x1 minus 1 into 1 minus x1, x1 minus 1. Fourth one minus x1, 6 into 1 minus x1, 8 x1 minus 5 into 1 x1. So these are the A's expected payoff. So for each one writing or drawing that one linear equation referring to this table, this matrix. Okay. So here also, here order of matrix is 2 by m. In previous problem n by 2, where columns are 2 but rows are more, whereas here 2 rows any number of column, that is 5 columns. So 2 column is that x1 and x2. For each one you have to draw one vertical line, x1 and x2, as I mentioned in previous problem, that convenient distance 8 centimeter or else 10 centimeter, divide it into 4 parts. Okay. Now scale here. x1 and x2, maximum positive value is 8. Okay. So positive value on each one you take 8. 1 centimeter equal to 1 unit scale. Okay, on positive side 8. Negative, most negative is, that is minus 5. Okay, referring to this table. So you can take minus 5, even more than that one. Here I taken up to minus 9. Okay, you can take up to minus 7, no problem. Okay, and go on drawing linear line for each pure strategy for y1, y2, y3, y4 and y5. For y1, x1 is minus 5. Okay, minus 5 here, put cross mark. x2 is 8. So minus 5 and 8. Yeah, see here. Minus 5 and 8. Minus 5 and 8. Okay. And 5 and minus 4. 5 and minus 4. Okay. This is y2 and the initial one y1. Third one 0 and minus 1. Okay. Here 0 and minus 1, this is y3. Okay. Similarly y4, minus 1 and 6. Minus 1 and 6, this is y4. y5, 8 and minus 5. 8 and minus 5, this is y5. This is how to draw that each linear line for y1, y2, y3, y4 and y5. Once you draw these lines, okay, whenever order of matrix is 2 by m, it means 2 rows and any number of columns. Okay, then find the lowermost boundary like this. Among this lowermost boundary, find the maximum intersection point. Intersection points are, this is 1, 2, 3, 4 and 5 here. Okay, among these 5 points, maximum uppermost boundary, okay, uppermost point, intersection point, lowermost boundary, maximum of this minimum. Why maximum of minimum? Because lower boundary, that is minimum. Among this minimum, maximum, it is maximum of minimum. It is intersection of, okay, this point is intersection of y1 and y3. Okay, so reduced matrix is this one. Okay, so this one is the reduced matrix. Initially the order of matrix is 2 by 5. Now it is reduced to 2 by 2. Okay, further can solve it by that arithmetic mean. Okay, as I explained in previous one. Okay, ornaments, row ornaments, difference of adjacent row, 8 minus of minus 1, that is modulus is 9, minus 5 minus 0, its modulus is 5. Here minus 1 0, modulus is 1. 8 minus 5 minus of minus 5, 13, modulus is 13. Column ornaments. Okay, now using row ornaments or column ornaments, determine the game value. If you use row ornaments, select any one of the column. If you select y1 column, 9 into minus 5, 5 into 8 divided by 9 plus 5, that is minus 5 by 14. Okay, if you use this y3 column, okay, here it is y3 column. Okay, if you use this y3 column, okay, 9 into 0, 5 into minus 1 divided by 9 plus 5, minus 5 by 14. Okay, this is game value. In both case, that is minus 5 by 14. Okay, even you can use column ornaments. If you use column ornaments, 1 into minus 5 and 13 into 0 divided by 1 plus 13, that is also minus 5 by 14. Okay, even you can use x2 row, 1 into 8 plus 13 into minus 1, that is minus 5 divided by 14. Okay, use row ornaments or column ornaments, you are getting same value. Okay, and next, this what is the percentage of each strategy? For x1, ornament 9 divided by summation of ornaments, that is 9 by 14. For x2, ornament 5 divided by summation of ornaments, that 5 by 14. Similarly, y1 strategy, ornament 1 divided by summation of ornaments, 13 divided by summation of ornaments. Okay, so for player A, strategies are only 2, those are optimal, that is 9 by 14, 5 by 14. For player B, among 5, y1 is 1 by 14, y2 is 0, y3 is 13 by 14 and y5 is 0. Okay, y4 and y5 is 0 both. Here y1, y2, y3 and y4. Here one more, that is 0 totally. Okay, totally 5 strategies. Okay, here initially given strategies are 5. Among these 5, at first strategy 1 by 14. Okay, because y1 here, y1 1 by 14, there no y2, 0. y3 is 13 by 14, y4 not here, 0, y5 0, and game value is minus 5 by 14. So minimum loss to player A is minus, why you are talking minimum loss you are considering, because it is negative. Minimum loss is minus 5 by 14 when it plays strategy x1 and x2 in this proportion. Similarly, maximum gain to player B, okay, when it plays strategies y1 and y3, the proportion of 1 by 14 and 13 by 14. Okay, this is how to solve that given payoff matrix by graphical method. So here the note, keep it in your mind, if payoff matrix is n by 2, find uppermost boundary and lowest corner, that is minimum of maximum. If payoff matrix is 2 by m, find lowermost boundary and uppermost corner, that is maximum of minimum, as you did here. Okay, if 2 rows, okay, any number of columns, lower boundary, maximum of minimum. Okay, uppermost corner. Okay, this is uppermost corner in the lower boundary. Okay, so this is how to apply graphical method. So in today's class we studied that implementation of dominance rule, okay, reducing of the matrix, and reduced matrix is either 2 by m or n by 2. Further, you reduce that matrix to 2 by 2 by graphical method, then implemented arithmetic mean to determine optimum strategy values and game values. So this study is mapping with CO4, okay, and that is formulation and solving of game theory models, and application of this today's topic. Game theory is a body of knowledge that deals with making decisions when two or more intelligent rational opponents are involved under condition of conflict or competition. Okay, so this type of situations usually arise in the field of business, industry, economics, sociology, and in military training. And these are the assignment questions. You go through this one. If you got any doubt, you can contact me. And these are the reference what I used for making these notes. And this is the additional link for your reference. Okay, you can go through this one. This is NPTEL course link. Here is out some more numericals. Okay, typical one. You can go through those. Okay, thank you.